Good morning, everyone. I'm Rishika Khanna, and I'm doing a fellowship on understanding sediment transport in tropical waters. And today I will be giving you some insights based on this. So, understanding sediment transport in tropical waters. The topics which I would be covering in my presentation is what is sediment transport study and why do we need to study it in tropical waters? What is the process of sediment transport? The importance and consequence of sediment transport in our waters. What are the technological interventions which are developed and which can be used in sediment transport studies? The pathways of sediment transport studies which we are pursuing in at MRC in tropical waters, and the skill development in sediment transport. So sediment transport, it is a mechanism by which the coastal erosion proceeds and it impacts the dynamics of water zones such as coastal rivers, um, estuaries and waterway navigation channels and harbor capabilities, as well as it affects the water quality and related issues such as aquaculture. uh, as many of you would be knowing, there are already many scientific studies going in Western and Nordic countries, but they are not curated for for our tropical waters. So, applying these frameworks directly from other parts of the world to our tropical waters is not a solution because our tropical waters have a very unique climatic conditions, sediment composition, aquatic ecosystem, and socioeconomic conditions, as well as taking into account our stakeholders' perspectives becomes important. So, our tropical waters need a targeted approach on several issues, such as marine traffic, waterway navigation, as well as shoreline vulnerability. The technological revolution provides us with very large variety of low-cost tools as well for our in-situ studies like sensors and gliders, which I will be covering, as well as sensing the satellite data, the open source modeling frameworks. All of this makes it easier for us to carry sediment transport monitoring in situ and management system, benefiting the tropical countries at a global level. So I would start what covers the process of sediment transport. There are three aspects. First, what the forces which initiate the sediment transport system, the significance of grain size in sediment transport, and how the movement of sediment transport takes place. So the energy input for initiating sediment transport is given by tides, waves, winds, and currents on the beaches and ports, inducing the coastal erosion, sediment transport, and accretion. So naturally, five different categories of initiating forces are there: water level changes, tides, waves, currents, and stream outflow. I will go through each of them one by one. Sea level changes result in emergence and submergence of coastlines, which start erosion and hence sediment transportation. The second category, tides. Tides are the oscillations of ocean waves, uh, ocean waters due to gravitational forces exerted by sea and the moon upon the oceans. So they move enormous amount of water 4 times a day and hence are capable of erosion. So they play an important role in nearshore dynamics. The third category, waves, are mostly created by winds, and the wave energy is generally dissipated in shallow waters by frictional interaction with seabed. The currents are created when wind blows over water surface, producing stress on the water particles at the surface and causing their movement in the direction of the wind. The last category, streams, are important for providing sediments and building depositional features like deltas. Now we come to the significance of grain size. Broadly, there are two types of grains, cohesive and non-cohesive. So cohesive sediments mainly contain mud or clay and they have particle sizes less than 4 micrometer in diameter. While the non-cohesive sediments, they contains sand and gravel and their particle sizes are usually greater than 64 micrometer in diameter. And the interaction of these two different types of grains amongst themselves differ largely. So hence the separate study is required. The cohesive sediments have a special features of aggregating together to form flocks of sizes generally in the range of 100 to 200 micrometer, and the process is termed as flocculation. The flocculation causes the sediments to settle faster on the bottom of the sea. To measure the flocculation, there is a term called suspended sediment concentration (SSC), which determines the formation of the flocks. And in highly turbid water, the value of SSC is generally greater than zero point 0.5 gram per liter, and it the value this high amount of value uh, pe- inhibits the light penetration and production of the phytoplankton, and it this makes the production of flocculation scarce, but they're abundant in less turbid water which have SSC less than zero point 0.1 gram per liter. Moving on to the movement of sediments, sediments generally move either as bed load or or suspended load. The bed load consists of coarser grain particles like sand or gravel, that is which belong to the non-cohesive category, and they while moving, they move via rolling or sliding, remaining in continuous contact with bed, while they jump along the bed in a series of low trajectories. The suspended loads they generally consist of finer grain particles like clay or silt, and they continuously flow in the water column without touching the bottom. So they are generally carried by turbulence. Now, what causes the movement of the sediments? So the main cause is when the frictional force between the flowing water and the seabed generates sufficient shear stress to overcome both the gravitational force as well as the friction between the sediment grains and the underlying bed. This shear stress is largely dependent upon the average current speed. The direction, moving on to the direction of the movement, generally the direction of net coastal sediment transport is perpendicular to the shore. Now we move on to the importance and consequences of sediment transport. So sediment transport and deposition are a lifeline for many ecosystems, either directly or indirectly. So it builds the aquatic habitats for spawning and benthing organisms, and they're essential. The sediment transport patterns are essential for replenishing the nutrients to aquatic plants and vegetation in near shore systems. And the sediment transported from watersheds to the downstream is deposited in deltas and mudflats. So this helps in maintaining wetlands, protecting against coastal erosion as well as effects of sea level rise. However, a perfect balance of the sediment transport and deposition cycle is essential, because even a slight diversion from equilibrium rate can cause ecosystem and safety issues. For example, too much sediment is responsible for water contamination, excessive algal blooms, and blockage of waterways, or altering their direction. The sediment can the deposition of sediments, a large amount of sediments can disrupt the aquatic migration cycles and harm the organs and gills of aquatic animals. And oxygen levels also fall when water temperature rise due to increasing sediment level, because sediments are generally absorb more heat than water. So to keep in check the sediment balance levels, there is a measurable unit given by total maximum daily load (TMDL), which establishes the limit of the measurable pollutants and parameters for a water body. Now, the technological interventions we have in sediment transportation studies. As I mentioned before, the bed load transport, the shear stress is proportional to the average current velocity, and the bed load transport rate is also proportional to the shear velocity, specifically shear velocity cube. So, to uh, to measure this the sediment load, the suspended and the bed load sediment load, we need average current velocity as a parameter, as a measurement parameter, and sediment concentration to get the bed load as well as a suspended load. For this, we have firstly we have our acoustic Doppler current profiler, which is an instrument which measures both the quantities, that is the average current velocity as well as the sediment concentration from a vessel underway. The the direction of the sediment transport is generally detected by either geomorphic indicators or or by tracking the movement through artificial tracers. The places of wave convergence and divergence, which provides the quantitative measurements of how much littoral drift and the direction of the littoral drift in local as well as regional areas, is given by wave refraction studies. There are also other sedimentological methods such as beach profiling and sediment budget, which analyze the sediment transport. This sediment traps study specifically is employed to measure the quantity of suspended sediment which sink in an aquatic system at a given place over a period of time. Now we move on to the some successful a successful case of sediment management, which is the Mekong River Commission in China. They have a discharge and sediment monitoring program called DSMP, which uh, which which measures weekly, monthly, and daily data of sediment transport in the river, recording of daily water levels, and all of their databases are available freely online on their website. Why do we need to take inspiration from this commission? Because the water system of Mekong River very closely resembles the tropical water system of India, and they can provide some useful insights on how to go towards a successful sediment management program. Now we are studying three different pathways in at MRC, that is river, coastal, and port systems. So I will go through why do we need three different pathways. A first reason is for effective resource management, because each of these systems have each of these systems are very critical as they have high siltation rates, and these three systems have different siltation types. So in each of them, desiltation efforts requires precise information on sediment deposition type, and studying them separately will help in effective resource management and development of by developing separate monitoring systems, prediction tool, and intervention strategies. So, thus we study these three different pathways through three different demographically important case studies, which addresses the diversity as well as the similarities of the systems, and our end deliverables or the end goals of studying these case studies are uh, developing a policy and technology interventions, and developing modules for acoustic capacity and capability building. So first, in the case studies is the tropical river system of Brahmaputra. It has a it has higher siltation rates than other Himalayan rivers, and origin of 80% of sediments in our tropical waters is from higher Himalayas. The Himalayas have rugged terrain, fragile geology, and uneven, intense rainfall, and supraglacial debris, which are the main cause of development of the sediments. The problems which arose from the high sediment siltation rates are the riverbank erosion, river channel blockages, damages of turbines, degradation of water quality, and disturbance of riverine ecosystem. So why we have chosen Brahmaputra specifically? Because the sediment transport load is relatively higher in Brahmaputra, which approximates to 721 metric ton per year as compared to other Himalayan rivers like Ganga. And Brahmaputra flows through three different countries, so making it of national importance and crucial in maintaining our international relations as well. And Brahmaputra is highly dynamic in nature, and the region surrounding it contains dense and largely poor population, so making it the center of economic development. Our case studies for coastal systems are Konkan Coast and the JNPT port, which lies on it. So the geographical features are that they have rugged terrain with many seasonal rivers which drain the coast. So they carry high silt loads, especially in monsoon, and they are typically marked by sea cliffs, dunes, caves, and shore platforms, which are important sedimentological features. Now, the disadvantage or the problems which high level sediment transport poses in the coastal system are the severe coastal erosion due to uh, due to shifting sediment transport patterns and obstruction of waterways and port channels due to siltation and ineffectiveness of sonar uh, for sensing in the tropical waters. So, why we have chosen Konkan system specifically? Konkan region has a 500-kilometer long coastline, so it covers the economically important areas of Goa and Maharashtra. And JNPT port, that is Jawaharlal Nehru Port, which lies on the Konkan coast, is one of the country's largest container ports and handles significant part of country's sea trade. And the studies of the Konkan coast form a prerequisite in coastal projects like ports and harbors, fisheries, and coastal protection, as well as land reclamation. Now, what is the way towards the skill development in our sediment transport system? For the first step towards it will be categorizing the different skilling levels as per the requirements of the industries. That is from the level of people who are on ground handling the equipments to the uh, people who are people who are sitting in the offices and uh, logging the data into the systems, and then building modules, different skilling modules at for each of the levels. The third step is identifying the stakeholders who will be responsible for implementation of these skilling modules, and the skilling modules which we will develop will be delivered as short-term and long-term courses, as well as a supplementary to major maritime courses. And as the dredging forms an important sector in sediment uh, transport system, the training and education in dredging and other desiltation industries will also become crucial. Okay. Thank you.